All right, so I just want to take a little time and do a quick video on this one, similar to what we did for the suspensions, but this time regarding the mainframes. This customer here has about 12 trailers that we take care of, and in the last couple weeks, all his older ones, we've just ordered 3 brand new ones to fix all these problems, but these older ones have had some issues that I've found with the majority of these mass production trailers. We'll just go ahead and start from the front. These main tongue tubes are 1/8 wall, so they get dented easily, they flex pretty easily, and when you get a lot of tongue weight or they get beat over time, they start to bend. They start to push the screws out of the front end. This one isn't so bad. We have one out in the parking lot that's a lot worse. But as we transition into the bottom, one of the things I don't like, well, one thing that's particularly is decent on this one is this front crossbar right here. A heavier piece of sheet metal that they bend around. It offers a little more structural strength. But what you'll notice here is you have an 1/8 inch I-beam, and then you have a 6-inch tube that runs into it for your side braces, for your tongue tubes. This I-beam is 3/16. Your tongue tubes are 1/8 inch thick. They're not, I've yet to see any 1/8 inch mainframe tubes that hold up to wear and tear over time. They either bend, they get dented, they break, they just don't hold up. And then another pet peeve of mine is these triple tubes. The advertisement for a triple tube tongue, they put a heavier tube in the center. I'm not really sure what they tried to do up here. Maybe this is supposed to be for a winch mount when they manufactured it, but they go into a piece of sheet metal that's literally just a floor joist to hold the plywood. And as you can see right here, it's starting to pull the joist down and buckle it right there. And if you'll notice, a true triple tube should come back. Whatever's sticking out of the front, you should have double that coming back into the mainframe. And this one is actually still tied to the angled pieces that go into the mainframe, so this center tube is completely useless. It's still tied into the main part of the tongue. There's no structural benefit to it. It doesn't help out anything. It's a big pet peeve of mine. I don't think it's good for customers not to know about it, because when you're shopping for a trailer, these are good things to look for. Another thing is these crossbars here. These are probably 6-inch crossbars here. They're a little shy of coming all the way to the bottom. You're not getting your true structural strength until you reach the bottom. And the same thing with these outriggers. This is the same height as the outriggers are the same height as the cross tubes, but you're not getting all the way to the bottom. So what you'll find is back in here, we actually cut the old outriggers out because the load from the axles were coming up and the box is trying to come down, and it breaks these out. And then when your crossbars aren't enough, it'll actually bend the main frame rails in from the boxes pushing down and bend the tubes in. And this one in particular as well, they didn't double. The double I-beam should have carried on past where the wheel box is and then had a bigger crossbar. If you'll notice over here, they did about a 7-inch crossbar, but it takes it to almost the bottom of the I-beam to give you a full structural support. They do that on these double I-beams because now the weak link is where the 2 I-beams are welded together at the top. So as you can see here, where we added in this crossbar and these outriggers, we did a full tubed outrigger here. We jacked the walls back up to relieve the frame and pull the frame back out, pushed the frame out, and then added in this 2x2 cross member. Now with this 2x2 cross member in here, you can see that the original cross member, the floor joist, is bowed from the frame getting squished in. It bowed this original cross member, so that gives you a reference point between what it would look like straight and what it would look like after it's been worked on for a while. It did crack the main frame back here. We ended up covering it up with the tube. And then sometimes, if you'll see, we'll grab another light here. All right, so now that we got a light, this is our outrigger that we replaced. This was the next one back, but it gives you an idea. This crack right here is where the top part of that flange is breaking, and it's knocking these outriggers apart. So the ones that we took out of here were broken all the way down on both sides, and the only thing that was actually holding it was the screws and the bolts that were holding the plywood to the floor. Structurally, it wasn't holding anything. Then one of the other things we noticed here is this piece right here was scabbed in. If you come around to this side, you're gonna see they just took an extra piece of I-beam, scabbed it in with some scraps off the floor, and that's how they got their extra extension. Now the good thing about this is where your wheel boxes are, and your main frame actually comes back, and then you go into your beaver tail. which slopes down. We'll get into that in a minute. But this is the better way to do it. Ideally, I'd like to use tube because I don't want to depend on these two. This weld on the top is now where all the load's going to when you go with a double I-beam frame. Having the taller crossbars in here obviously helps, and all of it tied together is what helps the most. But this still the fail point that I've seen, and I'm only speaking on the fail points that I've seen, is even when these crossbars are solid, now your weak point is where the two I-beams are together right here. They want to pull apart because your box wants to come down. Your axles, the energy from your hubs and your wheels are transferring into your mainframe here. So your mainframe's trying to go up and your box is trying to come down. This is why I preach to everybody, and when I get hired for consultations, I tell all my customers, we focus on the outriggers and how the mainframes are. We at Noma Fab do not build our trailers like this. We don't have traditional mainframes. We build our trailers completely different, which you can see in other videos or we can discuss another time. But right now we're just focused on these mass production trailers and what to look for. So wheel box failures are 95+% of the failures that I see in mass production trailers. I don't care if it's Hallmark, Look, Pace, Interstate, all of them. If they have outriggers, they're all building them the same way. And even if they're using tubed outriggers, they're not doing them as often. They're still having the same problems because they're too much load on the wheel box outriggers and not enough dispersed through the rest of the trailer. So, all right, so now getting back into the wheel box area, this is our go-to repair for our wheel box outriggers. We use a full tube, at least 3/16, usually a 1/4 inch tube. What we'll do is we'll cut out the old outriggers. Sometimes there's two of them. Usually there's only one. We'll clean it all up and then figure out a way to tie that tube into the outer wall. If you'll notice back here, we got a full weld here, a full weld down the frame here. We got a full weld down the frame on this side, and then we weld all the way across the interior here for the wheel box area, mostly to seal them up, tie all the sheet metal together to make it more structural. And then this is your upright that goes all the way to the top of the trailer. So we're tying that into the outrigger too. Now before we do this, we put jacks on here and lift the box up until it's almost bowed in. We try to overcompensate for what is the sag, because by the time you weld the outrigger in here, weld your crossbars and let it sit back down, it is going to settle a little bit. Another thing too is when you have your lifts all the way at the front and all the way at the back, we can bring it down, but it'll bow this frame down like this, which also relaxes the box a little bit more, straightens everything out. Now, one of the reasons that we could tell this side was failing right off the bat is if you'll notice right here, you can see the wheels were rubbing on all three axles. Because the box, when the outriggers were failing, the box was falling down, which is allow it to fall out, which is causing the wheel boxes, the tires to hit. Once we jack it back up, it'll pull it back through. Now this also could be from wear on the axles or allowing it to go in there. Some people say this is overloading problems. That's all true. These are all indicators that are a possibility. But in this particular case, you can see here it was hitting on all three. And if we walk around to this other side over here, we can see that it wasn't hitting anything. So none of them are actually hitting here all the way down. And if we check the distance between our backing plates and our main frame, they were equal on both sides. I don't think the weight difference of the trailer was significant enough to cause that issue. If you were to put a straight edge across the frame and hang it out to the edge of the box here, on that other side it was down about 1 inch, which would feel this out and allow the box to come down. So now that we've got the outriggers in there, jacked everything back up, there's definitely enough clearance now. So that's our biggest repairs in box trailers and our biggest fail points in all box trailers that we've found. And it's a great thing for us as a repair shop, but for a consumer, it's definitely something you need to look for, especially when buying a used trailer. Now in a couple of weeks, maybe another week or two, we ordered some new trailers from Pace with these outriggers already built in. We were very specific on the triple tube tongue. So I do want to let people know that it isn't per manufacturer or anything of that nature. It's how you order the trailer, how the dealers order the trailer, how the customer orders the trailer, who you have helping you order the trailers. We do consultations at the same time. When you're buying something, if you're only going to use it a couple times a month for 4 or 5 years, this is fine. But if you need something that's going to last you every day, this trailer is used daily, it's moved daily, it's got a big load in it, you're going to want to get these upgrades done so that you don't have the life of the trailer cut down. Let's go and take a look at the back. Okay, so another real common problem in these mass production trailers that you'll see in what we ordered aftermarket, or what we ordered from the factory this time, is this back crossbar. This back crossbar, generally speaking, is a bent piece of sheet metal, just as we saw in the front, just as you see here on this mainframe outrigger. It's just bent sheet metal. What I like to do is, they fail all the time because they get hooked and caught, and then the door hinges are actually attached to that bent piece. So what happens is they get hooked and they get bent up, and then the door doesn't work properly. So then this is a common repair that I see that I don't understand why people do, or one of the things I see people try to do is they put these skid wheels in here. And this particular job was done with, they put 2 bars in here. They tried to, it looks like they tried to build it outside of the trailer instead of building it in place, and then they tried to put it in. It came in a little too short, so they couldn't fit it in here. So in here, they welded just the bottom, and on this one, they welded on the inside. So when you weld to the back side of here in the bottom, you'll notice that the frame will stay straight if you don't box it in. Here, which is what happened most of the times, they'll either weld the skid wheel just to the bottom, right here, on this piece of channel, they'll weld just to the bottom, and you can see this one's been hooked and broken and everything else. They will weld just to the edge, and what happens is, this one in particular has pushed all the way up, and it pushed the floor of the trailer up probably a ½ inch where it's supposed to be. Peeled this mainframe member in, and all this stuff is preventable. And back here, instead of putting a piece of channel on, if you put a piece of tubing on here and you box this in, then all this is prevented and unnecessary. And you don't have to, it's structurally far more sound to box the plate in, replace this with a tube, get rid of skid wheels because they just take more clearance away. And what we do is we'll put a big skid plate back here, tying this whole corner in together with like maybe a 1/4 or ½ inch skid plate that's actually designed to drag. And if you do hit it, it's no big deal. See, and you're gonna see here where this tube here is actually crushed in. This is another symptom of the box collapsing down on the frame. So the outrigger's holding up on this one, and now this piece is the weak part, so it starts crushing it in here. What they did here is they put a piece of angle iron to hold this piece of tube back, but this piece of angle doesn't have anything stable to weld to. So you got to look and see where the energy is being transferred in order to make your repairs properly. There's a lot of willy-nilly like repairs that I see that make absolutely no sense to me, that we end up having to explain to the customer that we have to go back now, cut all this stuff out of here, and do it the proper way, or try to patch in what they have to make it make sense, and they wonder why it's more money, or they wonder why there isn't like a standard way to do this stuff. But these are also, this back cross member, this back area is also a huge common problem that we see in all these mass production trailers. All right, so here's another trailer just to compare apples to apples. It's a 28-footer. Going back to what we were talking about there's no manufacturer that's better than the other. In my opinion, this is a Freedom trailer, which has a reputation for not being a good trailer, but this one's actually held up pretty well. It's a 2015, so it's a 10-year-old trailer. Some things that I've noticed here, and one of the reasons why it's here, is this tongue has been replaced. What had happened was the tongue had bent, whether it be because it was overloaded or it got hit. I think it got hit by a truck and it bent the tongue in. But I want to talk about this repair here. First of all, these tubes are only 1/8 inch tubes. And with this length on the tongue, only being 1/8 inch tubes that are only 6 inches, with the amount of load that it's carrying, I've never seen them have very good luck. They've always been, they're susceptible to a lot more damage, a lot easier. But this particular repair, instead of going back and cutting out the existing tongue, they decided to scab over the existing tongue and then plate the bottom and then carry it out. The downside of that is the angle is now wider. So if it did get hit by a truck from the turn, when we do them, we actually make them narrower to try to prevent that from happening again. But neither here nor there, they decided to scab on the outside, which it's fine for the overlap. It's what they thought was fine. But if you'll notice here, this center tube is this bar is bent. It's taking stress and the load. You'll see some buckling up in here. All this energy is getting transferred up into the front wall. You'll see it buckled here. You'll see it buckled in here. Where this is coming down, you'll see that they only put a real thin piece of sheet metal here because that's all that was existing. So really there's nothing holding this tongue to the mainframe other than right here besides the front wall. And these front pieces of sheet metal are not holding up to the load of the leverage that it takes to hold up. And it's got every indication of it. Now you'll see this energy transfers not only through here, in this particular one, they cut it back in here. Okay, you can see they actually cut more structural integrity out of it here by cutting the original plate and then scabbing over it with this plate. All this takes away the integrity of the tongue. And with your center tube still only being tied to a floor joist, it should be coming back here with a crossbar that ties back into the mainframe. All your load is going from here to now the front wall. This pivot point here, right here, can't hold the torque load of the tongue, the box pushing down and the truck trying to hold it up. So what's happening, and you can see it right here, you can see indications of it everywhere through this whole front end, right? But where you see it on the outside of the trailer is you can see where they've added extra screws. You can see screws coming out on the front over there. You can see the front diamond plate, all the screws are popping out. They've added in extra screws. It's all buckling. The front wall, it has a little wave to it and buckle to it because all the load from the tongue is transferring now into the front wall because the tongue isn't properly tied into the mainframe with a true triple tube and transferring the load. Another thing that we do to transfer the load is from the mainframe here to our tongue, we put a real heavy plate here or another tube, which helps the torque load and it helps to triangulate the tongue going up to the mainframe. So it'll be touching in two places to keep the load on the mainframe instead of transferring into the wall. It's fine to use a piece of sheet metal here if there's another tube here or 2 points connecting here to keep the torque load out of it. So that addresses the tongue and why when we order trailers in our consultations with our customers, we ask that the tongues be the same size as the tube. This is an I-beam mainframe, so we would request a 8-inch tongue to be put on it. This is a 3/16 wall, thick wall I-beam, so we'd ask them to put a 3/16 thick tongue on it. We also ask that the center tube comes back at least 16 to 24 inches behind the main tongue, so they'd ultimately replace this crossbar with a tube, and that would be where our center tube ties into. So these are simple upgrades from the manufacturer that prolong the life of the trailer and actually make it prevent it from having these type of problems. So now if we get into what we were talking about on another trailer, we notice that all these crossbars on this trailer are full length. They're full length from the top to the bottom, just about full length. For mass production, we'll consider this full length. But that's helping the torque of the tube side to side. And it keeps the frame, the I-beam members straight. And you'll also notice here that the outriggers, the crossbar for the floor meets the outriggers, which meets the stud that goes up the wall. So that's carrying the whole load all the way through. Now, what I don't like on this particular trailer is that some places it doesn't meet and it doesn't match, and they're only welding it a little bit on the top if they're all welding it. So a lot of these are not stable. They're not plated in and welded all the way. So, but being that there's so much metal in here and there's so many outriggers that are welded just about the full length, there's enough material in here to prevent failure. And you'll see that they did that all the way down, whereas in the other trailer, the Pace trailer, had a 6-inch or 5-inch floor joist in it, which is decent for the floor, but it doesn't help the side load of the I-beams, the box pushing the I-beams in. And if we could take a look at the example up here, you see what they try to do here is they double up the outriggers at the wheel box area. So this is your wheel box area. They carried their I-beam past the end of the wheel box into here. So this is good to take that side load, but it's still only 2 pieces of little outriggers, bent sheet metal, and it's not really carrying the full load. And if you have an incident, for example, back here, they blew a tire out and it bent this outrigger and broke it out, and you can see where it starts to tear the weld and bend it all back. So, but again, the good thing is that the I-beam carried back past where the wheel box is. So now that when we put our outriggers in there and we tie our studs together, that will have a full load going into it, and then you have 2 cross members inside here. So if you notice under here, you have a full length crossbar on this I-beam, and then a full length crossbar on this I-beam, and then we're bringing our load in the side here. So even if it tries to twist them apart, it's going to be more difficult because you have a full crossbar that's keeping the torque load from happening so much. So that's why this is actually lived a longer life. This one came to us once before for a quick repair. The axles were bottoming out because there wasn't enough clearance. We've spoke about that in other videos. So what we did for the repair is we put the taller hangers in it from Dexter. We made some custom shackles, and as you can see, all these were bottoming out in the frame. We got the proper clearance. It doesn't have any indication of where it's been bottoming out anymore. We went ahead and added some gussets here because there was one of these back hangers had ended up breaking off through the whole process. So we just added some gussets here to tie the 2 I-beams together. Being that it was a double I-beam mainframe and the big crossbars in it, we didn't feel the need to crossbar all the way across. Generally speaking, we'll crossbar all the way across at each hanger, but being enough structure here, we just wanted to brace the hanger itself into both I-beams, and that'll keep your hangers from twisting off, even with the taller equalizer and a heavier shackle on it to give us our proper clearance. Now obviously it's lifted up in the air now, so it's dropped out a lot farther, but when they're up where they're supposed to be, we still have our 3 inches of clearance above it. So that's working out pretty good. So now as we move back further, we're going to see in this particular trailer, instead of having the beaver tail in it, they did a flat floor, which brings your I-beam all the way to the back straight, which gives us all our crossbars that are all top to bottom. So it's adding in much more structural strength. Now you'll see here, somebody's trying to scab in like a skid bar. It's failed. It's been worked on a couple of times. The back end has been hooked. We talked about this in previously too, where this is just a piece of sheet metal and it's holding the back door hinges on. And it's been dragged and hooked a couple of times, so they tried to fix it by tying it to this other piece. That doesn't work. So then they tried to put a skid bar in it. That didn't work. And now it's gotten to the point, and it's also gotten backed into something on that corner over there. So between this getting crushed in, and you can see there's no structure here. So the way we build it and the way we repair it is we'll actually remove the back door, put a full tube across the back of here, tie this corner all in. So if and when they do back it into something, you got kind of a bumper here. It might cause a little cosmetic damage, but it's not going to crush it in like this because there's no structural integrity in the frame itself. So that's another reason why this one's here is we're going to take this all apart, fix it, put a tube across the back, plate this all in, remove this, give us a couple inches more ground clearance, And between the tube and the skid plate that we put in with some 1/2-inch thick material, it'll prevent all these problems from happening again. And it's a relatively easy fix, whereas you saw on the other one, they tried to put a piece of channel in, but ultimately leaves you the same ledge to get hooked on. When you have a tube here, it's a lot less likely that when you hook a tube, it's gonna stick up high enough to actually grab it and pull it off. It has more of a tendency to slide over it. So we don't try to stop it from getting dragged, because we know that they're gonna drag one way or another, but we do try to plan for the drag and fix that. So this is another example of where our consultations help out, in the sense of, this is a customer, one of 12 again, that we ordered some trailers for them. We're ordering 2 main frames. So in our next clip, we're going to talk about the difference in the main frames, why we prefer tubes, if we go tubes, the wall thicknesses and the structural strength of them, why we decide to do what we do, how the load's transferred, and how we overcome a lot of these problems, so that you have a trailer that's 15 years old that's working out well, except for the foundation wasn't good enough to let it keep living. So, and it's used pretty regularly, but it still should be holding up a little bit longer than it is, and all these problems are preventable. And in our consultations, we save you money in the long run by spending a little bit more money up front and explain to you how and why that is. Again, to touch on which manufacturer is better, I'd like to point out the difference. And this is a Freedom trailer. It's considered to be a lower grade trailer. But if you look at this particular example, the structure of this trailer is actually held up better than the Pace trailer that was also built with the same I-beam. So I personally don't think that there's a better, I mean, it's personal preference, and obviously there's different applications that require different materials to be used, in my mind, and my personal preference. But at the same time, for how this trailer was built with the I-beams and the structure of it, in my opinion, it was built fairly well for what it is. And the details that actually matter to make it work are present in this trailer. So there's a couple, little details that I don't particularly care for, but in the overall scheme of things, it's held up well because the foundation and in the I-beam application was done properly. So again, it doesn't matter in my mind if it's an I-beam, if it's a tube, if it's a certain manufacturer. It's how the build is conducted and how all these little details tie in together to get you the ultimate product at the end that works out with everything considered. All right, so one of the biggest reasons why this trailer is here is because we're going to go ahead and replace this tongue with this repair for 2 reasons. 1, the tongue is actually wider than it really needs to be, and 2, it's not tied in properly. So what we're going to go ahead and do is cut it out from the existing point all the way to the front. We'll probably reuse things like the jack, the breakaway battery, the coupler. We'll save some right there for the customer. This center tube, we're going to do the same thing on both sides for that. Cut this completely out. The good thing about it is these floor joists will stay pretty much where they're at because they're screwed into the floor. And now that the trailer's built, we'll support the trailer from back in here with the lifts. So all this is free for us to do whatever we got to do. We're going to go ahead and take this front wall out here. We'll take all the trim off the front, take this front cross piece out. We'll build us a new tongue. We'll take our center tube and we'll notch out each one of these floor joists, and we're going to run our severance tube back and tie it into the frame with a tubed crossbar here. And by the time we're all said and done, we're going to use 8-inch tubing and, instead of 6-inch, and we're going to use 3/16 wall instead of 1/8 wall. So by the time we're done, the customer will have a narrower tongue that's tied in. It'll be at 1, 2, 4, at 8 points. So whatever hangs out here is only a half. It'll be less than a half of what it's actually going into the trailer. So that'll take out the whole load on the front wall. It'll eliminate the front wall load that's causing all the destruction on the front end, and we'll repair the front end, and then he won't have any problems after that unless it gets impacted again. Okay, so the other problem that this one has, and the reasons why it's here, is because this back door is not working properly for two reasons. One, the impact that happened here, and the other one, it's been hooked so many times in the middle that back crossbar is now waved, and it's affecting how the door performs. So what we're going to go ahead and do is we're going to remove these attempts for a skid bar. We're going to remove the door, the whole door in itself. Put a full tube back here, and tie the tube into the wall with a thicker plate, and put some skid plate along the bottom of here. So we'll give them 2 more inches of clearance. We'll give them a stronger rear jam, and that tube will hang out to the full outside of the trailer. So it'll give a lot more structural support out here, and we'll go ahead and fix all this cosmetic damage. But in the future, it'll, due to driver error, whatever happens, it'll take an impact a lot better and absorb more energy through the trailer. Okay, so the question of what brand is the best or what manufacturer is the best, I don't have an answer for that. I don't believe in that. What we specialize in here, and what our consultation services specialize in here, is that we get real intimate with our customers, find out what they need to use it for, what the expectations they have for the trailer, and for how long. At that point, we go and either custom order a trailer from a mass production manufacturer that has all these fail-safes in it, all these upgrades in it, that we end up fixing it year after year after year. Or if they need something even above that, then we go ahead and build it here in-house, and we offer lifetime warranty on our trailers, frame warranties on our trailers, lifetime guarantees. And if the customer needs to save a couple dollars from there, then we go to a mass production trailer and we special order it to get the most life out of it that we can for what they want to use it for.